All right, class, we're going to talk about 7-2, similarity and transformations. I'm going to try to use this Elmo document and see if y'all like this or if you like the PowerPoints on the smartboard. A similarity transformation is a dilation or a composite of one or more dilations and one or more congruency transformations. Two figures are similar if and only if there is a similarity transformation that maps one figure to the other figure. Remember, translations, reflections, and rotations are congruency transformations. Dilation is the similarity. So let's look at example 1 here. Draw and describe dilations. Apply and graph the dilation D to the polygon with the given vertices. Describe the dilation. Okay, so what we're going to first do is we're going to graph what is given. So we have point A, point B, and point C. Okay, then we're going to use our dilation of 3. Take point A, apply the dilation, and then get your A prime. So A prime is going to be 3, 3. Then apply the same dilation to point B to get your B prime, 9, 3. And then to point C to get your C prime, 9, 6. Okay, once you've applied the dilation, you have to describe the dilation. Okay, so the dilation is a scale factor of 3 because we multiplied each coordinate of the vertice by 3. A little review here. We've done this previously this year. Okay, example 2. Apply the dilation. Here's your rule. Taking each coordinate and multiplying it by 1/4 to the polygon with these 3 vertices. Name the coordinates of the image points. Describe the dilation. Okay, so let's take each point. We have our pre-image point, -8, 0. Once we apply the dilation, we get D prime, -2, 0. Take your next point, E, -8, 4, apply the dilation, E prime, -2, -1. Last point, F, -4, -8, apply the dilation, F prime, -1, -2. This is a dilation with a scale factor of 1/4. Two polygons here. Our first polygon is the ABCD. ABCD. When I graph that, I have a quadrilateral. Then we have our image, what we end up with. So H, J, K, L. So we need to start thinking dilation. Looks like we started with the large quadrilateral, ended up with the reduction here. So how can I get from -6 to -2? -6 times what will give me -2? So x is going to be 1/3. That's going to be what our dilation rule. So let's see if it applies. Take each point and multiply it by 1/3 and make sure you get what's on the image point. yes, it works. So, polygon ABCD is similar to polygon HJKL by dilation with a scale factor of 1/3. Okay, last one here. So we're going to graph our pre-image, which is the PQRS. End up with our image, which is W, X, Y, and Z. Okay, so our dilation is 5/2. If you can't figure that out, right here on the side, I take 2 times what, and it gives me 5. Solve it like an equation, so I get 5/2. So now I need to apply that to each coordinate. 2 times 5/2 is 5, 0 times 5/2 is 0. 2 times 5/2 is 5, 4 times 5/2 is 10. 4 times 5/2 is not 8. Got that circled, something's wrong there. 4 times 5/2 is 10. 4 times 5/2 is not 8. It should be 10. 0 times 5/2 is 0. So, we've got polygon PQRS, and this here means it is not similar to polygon WXYZ, and why? Well, we have P here. Let me zoom out here. We have P that maps to W, and we have Q that maps to X. However, R does not map to Y, and S does not map to Z. You only have to give one example of where it does not map in order for it to not be similar. That's it for the first part. Have a good one.